Section 11.8, Objective. I can find the nth term of a binomial expansion. We saw yesterday that with Pascal's triangle, we can do a binomial expansion using the triangle for coefficients. But that can get really tedious if we have something that, say, is the 25th row of the triangle. That's going to be really hard to reproduce. So it turns out that there's something called the binomial theorem, which allows us to expand a binomial using combinations. Okay? And it says this: if n is a positive integer, then any binomial to the n power can be found by, or can be expanded by using combinations by term number. So this is going to be n combinations taken 0 at a time, a to the n, b to the 0, plus n of 1, a to the n minus 1, b to the 1, plus n 2, n combinations taken 2 at a time of a n minus 2, b to the 2, plus n combinations 3, a to the n minus 3, b to the 3, plus all the way down until we get n combinations of n, a to the 0, b to the n. Okay? So this theorem always works in any binomial expansion. So for example, if I want to do x plus y to the 5th power, okay, so that's going to be 5 combinations of 0. Now in this one, a is x, so that's x to the 5th, and b is y, y to the 0, plus 5 combinations of 1, a to the 5 minus 1, or I'm sorry, x to the 5 minus 1, or 4, y to the 1, plus 5 combinations of 2, x to the 3rd, y to the 2nd, plus 5 combinations of 3, x to the 2nd, y to the 3rd, plus 5 combinations of 4, x to the 1, y to the 4, plus 5 combinations of 5, x to the 0, y to the 5th. Notice that the number of combinations you're taking always matches the power on the b term, which in this case is y. Okay? Then if we write out the combination, this is 5 factorial over 5 minus 0 factorial, 0 factorial, plus 5 factorial over 5 minus 1 factorial. Whoops, I forgot. Sorry, getting ahead of myself here. X to the 5th, y to the 0, plus 5 factorial over 5 minus 1 factorial, 1 factorial, x to the 4th, y to the 1, plus 5 factorial over 5 minus 2 factorial, 2 factorial, plus 5 factorial over 5 minus 3 factorial, 3 factorial, x to the 2nd, y to the 3rd, plus 5 factorial over 5 minus 4 factorial, 4 factorial, x to the 1, y to the 4th, plus 5 factorial over 5 minus 5 factorial, 5 factorial, x to the 0, y to the 5th. So notice that this becomes 5 factorial over 5 factorial, 0 factorial, 5 factorial over 4 factorial, 1 factorial, 5 factorial over 3 factorial, 2 factorial, 5 factorial over 2 factorial, 3 factorial, plus 5 factorial over 1 factorial, oops, should be 1 factorial, x to the 1, y to the 4th, plus 5 factorial over 0 factorial. 5 factorial, x to the 0, y to the 5th. Now notice, when you simplify the combination, this first number matches the power on the a term or the x. The second number in the denominator matches the power on the y. So 4 matches this 4, 1 matches this 1. 3, 3, 2, 2. Okay, also notice that the powers add up to n in each one of these. Okay, so the powers have to add up to n. Now from here, it's just a matter of simplifying. This is equal to 1. This is equal to 1, so this is just x to the 5th. This is equal to 5, x to the 4th, y to the 1. This is equal to 10. This is also equal to 10. This is going to be equal to 5. And this is going to be equal to 1. Okay? And if you check your Pascal's triangle, you'll see that the 1, 5, 10, 10, 5, and 1 are the proper coefficients. All right. So, example. Find the first 4 terms of the expansion of x minus y to the 15th. Okay? Now, in this case, our a term is x, but our b term is negative y, and our n is 15. So, it's going to be 15 combinations of 0, x to the 15, negative y to the 0. That's our first term. The second term is going to be 15 combinations of 1, x to the 14, negative y to the 1. That's the second term. Then 15 combinations of 2, x to the 13, negative y to the second. That's the third term. And then the fourth term, okay, now notice that this is the fourth term, but the exponent on the y is a 3. That's going to be important later on. Now it's just a matter of simplifying. So this is 15 factorial over 15 factorial 0 factorial, x to the 15, negative y to the 0. Plus 15 factorial over 14 factorial 1 factorial, x to the 14, negative y to the 1, plus 15 factorial over 13 factorial 2 factorial, x to the 13, negative y to the 2, plus 15 factorial over 12 factorial 3 factorial, x to the 12, negative y to the 3rd. Now simplifying, this just equals 1, this just equals 1, so that's x to the 15. But this is a negative to the 1, so it's going to be a minus. This simplifies down to 15, x to the 14, y to the 1. Then y is negative, but this is an even power, so it's going to be plus. And this simplifies down to 105. X to the 13, y squared. And then my next one is going to be minus, and then it's going to be 455, x to the 12th, y to the 3rd. So the first 4 terms of that expansion are represented by, this is the first one, this would be the second one, third one, and fourth one. And again, notice this is the fourth term, but the power on the y is 3. Okay? Right, so that becomes very important to find a specific term. So, to find a specific term, the k plus 1 term of the expansion of a plus b to the n is always found by n factorial over n minus k factorial, a to the n minus k, b to the k. Or we could write that in combinations like this. So both of those say the same thing. One's just written in combination form. So example, I want to find and simplify the fourth term of the expansion of x plus y to the 12th. Okay? So k plus 1 equals 4. I want the fourth term. So the fourth term, then k is going to equal 3. So the power on the second term, or the y term, is going to be 3. So it's going to be y to the 3. So then it's going to be x to the what? Because remember, the exponents have to add up to 12, so it's going to be x to the 9th. Then it's going to be combinations of 12 things taken 3 at a time, or 12 factorial over 9 factorial, 3 factorial, x to the 9th, y to the 3rd. Then to simplify that, this comes out to 220, x to the 9th, y to the 3rd. So this would be the fourth term of the expansion. Okay? Now we can also find a specific term containing a specific power. So example, find the term containing x to the 5th in the expansion of x plus y to the 12th. Okay? Well, if x is to the 5th power, what does the power on the y have to be? Remember, it has to add up to 12, so it has to be 7. So then it has to be combinations of 12 things taken 7 at a time, or 12 factorial, 5 factorial, 7 factorial, x to the 5th, y to the 7th. And this simplifies down to 792, x to the 5th, y to the 7th. So in the expansion of x plus y to the 12th, the term that has x to the 5th is going to be 792, x to the 5th, y to the 7th. Now, which term would this be in the expansion? Okay, remember, it's one more than this power. So this is going to be the 8th term. So if I wrote them all out from term 1 all the way through, this would be the 8th term. All right, now here's an example where we have numbers with our variables. So example, find the term containing y to the 3rd in the expansion of 2x minus y to the 8th. Okay, so in this case, my a term is 2x, my b term is negative y. Okay, so I want negative y to the 3rd power. So that means 2x is going to be to what power? That's right, the 5th power, because the powers have to add up to 8, and then it's going to be combinations of 8 things taken 3 at a time, or 8 factorial over 5 factorial 3 factorial, 2x to the 5th, negative y to the 3rd. So this multiplies out to 56. And then I'm going to have times 2 to the 5th, because I have to distribute this in, x to the 5th, and then it's going to be negative y to the 3rd. So this is going to make it negative. This is 32, x to the 5th, y to the 3rd. Multiply that, we get 1,792, x to the 5th, y to the 3rd.